Yeah, day 12 part 2 took me a little while, to be honest. I've spent the last couple evenings chipping away at it, but I just got the answer for it, so I'm going to walk you through. I needed some time to think about it off camera, and I'll just walk you through what my solution was. So let's just go back to it here. These are all out of order. What happened? So essentially, it gives us this the same instruction set, but the meaning of them is switched. So instead of north meaning move the ship north, we have a waypoint, and this waypoint starts relative to the ship 10 degrees or 10 clicks east, and then at 1 north. So I created a new class, the ship part 2 class. This waypoint, I decided to just have, I realized I could have just simpler code and logic around this if the waypoint's coordinates were relative to the ship. And so I left a note to myself that the waypoint coordinates are always relative to the ship, where the ship x and y are absolute coordinates on the grid. And then I have a handle function similar to the way I did it for the ship number 1. And then this forward, the meaning of this instruction this time is to move the ship in the direction of the waypoint. And then the waypoint stays in the same position relative to the ship. So a forward movement means to move it relative to the waypoint, and so we take this value that's an integer, we multiply it by the waypoint x, and so that it basically has this ratio of movement to the x and y direction of this magnitude times the relative position of the waypoint. So we can either, there's one of 3 things that can happen. Either the ship moves toward the waypoint, we either rotate the waypoint around the ship in increments of 90 degrees, or we move the waypoint in absolute terms up, down, left, or right. I guess it's absolute and relative terms. You're moving it relative to the ship, northeast, southwest. Yeah. Yeah, the meaning of that is the same. Okay, so when we move the waypoint, that one's pretty straightforward. If the direction that they give us is north, then you move it up 1, or up by the value that they give you. If it's east, you move it. You move this x. Remember that positive x direction in our scheme here signifies east, and negative direction signifies west. And then this waypoint y, you subtract the value, and then blah blah blah. The west is you subtract it as well. And then I also normalized the instructions to these north, south, east, west directions, just to take the instruction that they give us and just normalize that to ship coordinates, or not coordinates, but directions here. So yeah, the hardest thing here was these rotations. I was initially thinking of using trigonometry to do it, and then just like taking the cosine of figuring out the angles. And then I stumbled across something on the internet where, there's just a simple formula for a 90-degree turn. If we're assuming that the origin is if we're assuming that the waypoint is relative to the ship, we can assume that the ship is 0.00. It's the origin, and that greatly simplifies this equation. And when you rotate a point 90 degrees around the origin, no matter where it is, it turns out that you can easily just get it at the y negative x value. So you basically swap the x and y values and make the y value the negative of the x. And so I just had these 3 equations. Obviously, a 360 degree turn just puts it back where it was originally. And so I have this formula where this is a map of the degrees to the formula that we need. And if you're rotating clockwise, then this formula assumes clockwise. And so a clockwise rotation of 90 degrees is just straight up whatever this is. the counterclockwise one, we take the degrees and subtract them from 360. So you can think of a 90-degree rotation clockwise as being equivalent to a 270-degree rotation counterclockwise. And if you look at the unit circle, that'll become very apparent. So let's say we have a 90-degree counterclockwise turn. If you subtract that from 360, you end up with 270. And so it's effectively the same formula. So we can reuse these rotation formulas for clockwise and counterclockwise rotation. We just have to compensate by subtracting from 360. So we basically take the current waypoint x and y, plug that into the formula that we get, and just this returns a pair. We take the first for the x, the second for the y. And it took a while to get this right. My code worked on the test input that they gave me, but then it wasn't working on the full input because I had swapped the x and y values in one of these formulas. But yeah, so I basically just wrote a test that walked through each step of the example input that they gave us and just checked the ship.x, ship.y at every point. If there was a rotation of the waypoint, I checked that. If there was a movement, I checked both the ship coordinates and the waypoint coordinates to make sure that these are still, even after moving the ship, the waypoint coordinates are relative, not absolute. And then just checking the distance, and then I wrote my own with a counterclockwise rotation because that wasn't in the example, just to test that. So I did a lot of tests that helped pin this down, because there's a lot of subtleties. There's a lot of surface area for bugs in this problem. But overall, I was able to plug in the full input, get the distance. I was surprised that the distance was actually, because in the example that they give us, this distance using this instruction set is 439, and then using the second one, it's lower by half. And yet, when I plugged in the full input, I actually got a larger answer than the one I got for the first one, by a lot. My first answer was 439, second one was 12,385, and so you can't really make any assumptions about the magnitude of these values. But I have my code committed to my repo. This is going to be a quicker video just because I've already solved it. I'm not solving it live. Just needed more time to think about it, and so I hope this was helpful. Definitely look up some images of the unit circle and these formulas just to confirm them for yourself as you're working on it. So hope this was helpful. This was a tough one. Yeah, it took a while, but it feels good to be done. So I will see you in the next one.